Namaste children. So how are you all? I hope you are fine, and we are discussing the first chapter, rational numbers. Till previous class we studied about the properties of rational numbers. Now the use of properties we are going to discuss in this class and their applications in solving the problems. So now we will discuss exercise number 1.1, question number 2. Write the additive inverse of each of the following. What is additive inverse? When we add two numbers and their sum is 0, then each number is the additive inverse of the other number. So we get the additive inverse of a number by changing the arithmetic sign, that is plus as minus and minus as plus. Is it clear? Yes. See the first question here, we have additive inverse of 2 by 8 is minus 2 by 8. Minus 2 by 8. So here we have plus sign is there, so we get the minus sign. And by adding these two numbers we get 0. Therefore, the additive inverse of 2 by 8 is minus 2 by 8. The third weight is there, here we have minus 6 divided by minus 5. This rational number is not in the standard form. First you convert this rational number to the standard form, then write the additive inverse. Yes. How do we convert a rational number into standard form? Yes. By multiplying both numerator and denominator with minus 1. Multiply numerator and denominator with minus 1. So what we get? The rational number in the standard form. Minus into minus plus 6 into 1. 6 divided by minus into minus plus 5 into 1, 5. So minus 6 by minus 5 is equal to 6 by 5. It is in the standard form. Now multiplicative inverse of 6 by 5 is, yes, minus 6 by 5. The same minus 6 by 5 is the additive, sorry, not multiplicative inverse, it is additive inverse. Therefore, the additive inverse of minus 6 by minus 5 is also minus 6 by 5. So here we need to convert the given rational number in the standard form, then we have to write its additive inverse. Now see the fourth bit, here we have 2 divided by minus 9. So this is also not in the standard form. Convert this to the standard form, that is by multiplying with the numerator and denominator with minus 1, we get plus into minus minus, 2 into 1 2, minus 2 divided by minus into minus, it is plus, 9 into 1 it is 9, 2 by minus 2 by 9. Now additive inverse of minus 2 by 9 is plus 2 by 9. Additive inverse of minus 2 by 9 is plus 2 by 9. Therefore, additive inverse of 2 divided by minus 9 is equals to 2 by 9. So convert the rational numbers which are not in the standard form to the standard form, then you write the additive inverse. So like this we will find the additive inverse of the following rational numbers. Now we will discuss the third question. Verify that minus of minus x is equals to x for x is equals to 11 by 15. So what we have to verify? Verify in the sense it is check that minus of minus x is equals to x. So write the statement which is given. What is that? It is minus of minus x is equals to x. We need to prove LHS is equals to RHS. If you verify or if you check LHS is equal to RHS by substituting the value of x as 11 by 15, then it is verified. So substitute x is equals to 11 by 15 in the place of x, then we get minus of minus x is equals to 11 by 15, that is equals to x. Now multiply here minus in the sense minus 1. Multiply their two rational numbers. When we multiply the two rational numbers, first multiply the arithmetic signs, that is plus into plus plus, minus into minus is plus, plus into minus it is minus. So multiply minus into minus, again bracket in the sense of, that is into, minus into minus plus 1 into 11 it is 11 by 15, that is equals to, here x is equals to what it is given? 11 by 15. So RHS what we got? 11 by 15, and LHS we got 11 by 15. That is LHS is equals to RHS. Hence it is verified. Hence it is verified. So like this we can verify the given statements. Given statement of minus x is equal to x for the given rational numbers. So now we'll move to the next question. Now the fourth bit. Write the multiplicative inverse of each of the following. So what is multiplicative inverse? Yes, when we multiply two rational numbers or two numbers, if their product is 1, then each number is the multiplicative inverse of the other number. So when for rational numbers, how do we write the multiplicative inverse? By interchanging the denominator as numerator and numerator as the denominator, we get the reciprocals or the multiplicative inverse. Multiplicative inverse is also known as the reciprocal. Yes, here the first bit here minus 13. So the multiplicative inverse of minus 13. Minus 13 means what does it mean? Minus 13 is equals to minus 13 by 1. Minus 13 by 1. So p by q form it is an integer. Integers can be written in the form of p by q as minus, that is that minus 13 as minus 13 by 1. Therefore, the multiplicative inverse of minus 13 is that can be written as minus 13 by 1. So the multiplicative inverse is the denominator will become the numerator and the numerator will become the denominator. That is 1 divided by minus 13, or in standard form we can write minus 1 by 13. Minus 1 by 13. Now the second bit it is minus 13. The multiplicative inverse of minus 13 by 19. Yes, that is interchange the denominator as numerator and numerator as the denominator. That is 19 divided by minus 13, or minus 19 by 13 also we can write in the standard form. Now the fourth bit here it is two rational numbers are given. Minus 5 by 8 into minus 3 by 7. Two rational numbers are given. Find the product of these two rational numbers. Next to that product you write the reciprocal or the multiplicative inverse. So minus into minus plus 5 into 3, 5 3s are 15 divided by 8 into 7, 8 7s are 56. Now the multiplicative inverse of 15 by 56. The multiplicative inverse of 15 by 56 is the multiplicative inverse of minus 5 by 8 into minus 3 by 7. So multiplicative inverse of 15 by 56 is equals to 56 divided by 15. Therefore, the multiplicative inverse of minus 5 by 7, minus 5 by 8 into minus 3 by 7 is 56 by 15. 56 by 15. Yes. So like this we will find the multiplicative inverses of the given rational numbers. Yes. Now question number 6. Multiply 6 by 13 by the reciprocal of minus 7 by 16. So we have to multiply two rational numbers. One it is 6 by 13, the other one is the reciprocal of minus 7 by 16. Yes, what is the reciprocal of minus 7 by 16? Yes, it is 16 by minus 7 or minus 16 by 7. So write the first write the reciprocal of minus 7 by 16 is minus 16 by 7 or 7 by minus 16. Now find the product. Therefore 6 by 13 into the reciprocal it is minus 16 by 7. Multiply plus into minus minus 6 into 16. 16 6 are 96 divided by 13 into 7, 13 sevens are 91. Therefore, the required product is what? Minus 96 by 91. Minus 96 by 91. Now, the next question number 9. Is 0.3 the multiplicative inverse of 3 1 by 3? Why or why not? Question. Is the 0.3 is the multiplicative inverse of 3 1 by 3? Find first the multiply. If you multiply these two, we should get the product as 1. If we get the product as 1, then we can say that yes, it is the multiplicative inverse. Or find the multiplicative inverse of 0.3. Multiplicative inverse of 0.3. That is equals to 0.3 is equals to what it is? 3 by 10 in fractional form. That is P by Q form. Simply, or you can write 0.3 is equals to what it is? 3 by 10. Now, the multiplicative inverse of 3 by 10 is 10 by 3. 10 by 3. Write this 10 by 3 in the what? Mixed fraction form. So, when we divide with 10 with 3, 3 3s are 9, 10 minus 9 is 1. So, mixed fraction is 3, 1 by 3. So, what is the multiplicative inverse of 3 by 3? 3 by 10, that is 0.3 is 3, 1 by 3. So, yes, it is the multiplicative inverse. So, yes, the multiplicative inverse of 0.3 is 3, 1 by 3. Now, if you want, we can multiply this in the other way also. That is, in the other way also you can find that. Multiply both the numbers. 0.3 is multiplied with 3, 1 by 3. That is equals to 0.3, write the decimal form. That is fractional form, which is given in the decimal form. 0.3 as 3 by 10 into, convert this into improper fraction. 3 into 3, 9, 9 plus 1, 10. 10 by 3. That is 3 into 10, 30, divided by 10 into 3, 30. 31s are, that is 1 by 1, which is equals to 1. So, the product we got 1. The product of these two numbers is 1. Therefore, it is, therefore 0.3 is the multiplicative inverse of 3, 1 by 3. The multiplicative inverse of 3, 1 by 3 is 0.3. So here, yes, the multiplicative inverse of 3, 1 by 3 is 0.3. So question is 0.3 the multiplicative inverse of 3, 1 by 3. Why or why not? Yes, you can write 0.3 is equals to 3 by 10 and the multiplicative inverse of 3 by 10 is 10 by 3. That is 3, 1 by 3. Therefore, yes, the multiplicative inverse of 3, 1 by 3 is 0.3. And or the other way also you can do 0.3 into 3, 1 by 3. That is the product we got 1. Hence 0.3 is the multiplicative inverse of 3, 1 by 3. Have you understand this? How we have found this, verified whether it is a multiplicative inverse or not. Clear? Now we will discuss example 5. Find 2 by 5 into minus 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 5. You have to simplify using the, find its value using the properties of rational numbers. So what is given here? It is 2 by 5 into minus 3 by 7 minus 1 by 14 minus 3 by 7 into 3 by 5. You see here we are subtracting or we are adding, we are subtracting 1 by 14 from this product. So if you we are adding minus 1 by 14 to this product. So by using commutative property, that is irrespective of their order, by adding any two rational numbers in any order, their sum is same. Their sum is same. So you bring that change to that last by using the commutative property. Now it is 2 by 5 into minus 3 by 7 minus 3 by 7 into 3 by 5 minus 1 by 14. So what property we use here? It is commutativity. Commutativity under addition. Yes. Now you see this, interchange these products. So what we get, A into B as B into A by using again commutative property and multiplication. So minus 3 by 7 into 2 by 5 plus this as minus 3 by 7 into 3 by 5 minus 1 by 14. So I have interchanged this number, that is A into B, I wrote as B into A. A into B as B into A. So which property you will again here it is commutativity. Commutativity under multiplication. Commutativity under multiplication. Multiplication. Yes. And this is commutativity under addition. The first one. Yes. Now simplify. Observe this. A into B plus A into C. A into B plus A into C. What property it is? A into B plus A into C. It is distributive property. A into whole, B plus C as A into B plus A into C. Where A is equals to minus 3 by 7 into B is equals to 2 by 5 plus C is equals to 3 by 5 minus 1 by 14. So which property it is? Distributivity. Distributivity property. Distributivity property. Now simplify this. So what we get as minus 3 by 7 into. So add the like fractions. You just add the what it is numerators. 2 plus 3 is 5. 5 by 5. 5 by 5 minus 1 by 14. That is 5 ones are 5. 5 ones are 5. We get 1. We get 1 into minus 3 by 7 is equals to what we get? Minus 3 by 7 only we get. And minus 1 by 14. So here what property we used? Again it is identity property. Minus 3 by 7 is multiplied by 1. We get minus 3 by 7. That is minus 1 by 14. Now you take the LCM for 7 and 14. LCM for 7 and 14 it is 14. Now 7 2s are 14. 7 2s are 14. 2 into minus 3 it is minus 6. Keep minus. 14 ones are 14. 1 into 1 it is 1. Implies minus 6 minus 1 is equals to minus 7 by 14. 7 ones are 7. 7 2s are 14. Therefore minus 1 by 2. So that value is equals to what it is? Minus 1 by 2. Therefore 2 by 5 into minus 3 by 7 minus 1 by 14 into minus 3 by 7 into 3 by 5 is equals to minus 1 by 2. So like this, using the properties we can find the values in the simpler manner. Yes, how much we got this? Minus 1 by 2. Is it clear, children? Yes. Now we'll move to the next concept, that is representing rational numbers on the number line. Yes, now we'll discuss representation of rational numbers on the number line. So before discussing the rational numbers, let us discuss natural numbers. How do we represent natural numbers on the number line? Yes, we will draw horizontal line, yes, like this, and which extends endlessly in one direction, that is right side of one. This is 1. And at equal distances will represent next natural number is 2, then 3 and 4, 5, 6 and so on. So it extends right side of 1. The line extends right side of 1 indefinitely. So how do we represent whole numbers on the number line? Whole numbers. So whole numbers, they starts with 0. They starts with 0. Yes, similarly we represent the whole numbers like what we represented natural numbers. So the first number is 0, then at equal distances we represent 1, 2, 3, 4, 5 and so on. So this is the way of representing whole numbers. Now integers, how do we represent integers? Integers, yes. So integers, we have negative integers and positive integers are there, and this line extends on both the sides endlessly. So at the middle we will take it as 0, and at equal distances from right side of 0 we will take positive integers as plus 1, plus 2, plus 3, plus 4 and so on. Similarly on the left side of 0, we will take it as minus 1, minus 2, minus 3 and so on. Endlessly. This line will extend endlessly on both the sides. Now do you find any natural number between 2 and 3? No natural number is there between 2 and 3. Do you find between 3 and 4? No natural number. 4 and 5? No natural number. Do you find any natural number between 1 and 3? Yes, 2 is there, only one natural number is there. Now, do you find any natural numbers between 1 and 4? Yes, 2 and 3 is there. That is, if the natural numbers present, there are definite natural numbers are there, means limited number of natural numbers are there between two natural numbers. So what about whole numbers? You will see. Between 0 and 1, there is no whole number. Between 1 and 2, there is no whole number. Between 2 and 3, no whole number. That is, between two consecutive whole numbers or successive whole numbers, there is no whole number. Now, between 0 and 3, we have 1 and 2 whole numbers are there. So, means here also we have a limited number of whole numbers will be there between two non-consecutive whole numbers. Similarly, integers. So here between minus 1 and 0, no integer, 0 and 1, no integer, but minus 1 and 1, we have one integer is there, that is 0. So similarly here also we will find a limited number of integers between two non-successive or consecutive integers. Now how do we represent rational numbers? Yes, rational numbers. See here, so rational numbers are infinity and we have the number line like this. So it is, this is 0 and it is 1, it is 2 and this is minus 1 and it is minus 2. Yes, all these are rational numbers. So between 0 and 1, we can represent rational numbers. For example, 1 by 2 if you want to represent, 1 by 2 is more than 0 and less than 1. Means it lies between 0 and 1. So here the denominator is 2. Divide the space between 0 and 1 into two equal parts. That is, this is 1 and it is 2. So this will give you what? 1 by 2. This point will give you 1 by 2. Means between two consecutive numbers 0 and 1 we have rational numbers are there. Only one rational number is there. We have infinite number of rational numbers. For example, if you want to represent minus 1 by 3, then divide the space between 0 and 1 into three equal parts. So divide the space between 0 and 1 into three equal parts. 0, it is 1 and it is 2. This is minus 1 and it is minus 2. Into three equal parts. 1, 2 and 3. So this will give you 1 by 3 and this is 2 by 3. This is 3 by 3 means it is 1. So this value will be 1 by 3. So here between 0 and 1, we have 1 by 2 is there and 1 by 3 is there. Like this, we can find infinite rational numbers between any two rational numbers. Infinite rational numbers between any two rational numbers. So like this, we can represent rational numbers on the number line. 1 by 3 means divide the space between 0 and 1 into three equal parts, and the first part will give you 1 by 3, then 2 by 3, then 3 by 3, which is 1. Like this, we can represent. For example, if you want to represent minus 1 by 2, so minus 1 by 2 lies between 0 and minus 1 by 2. So minus 1, 0 and minus 1. So now divide the space between 0 and minus 1 into two equal parts. Yes, this is one part and this is the other part. So this will give you minus 1 by 2. Minus 1 by 2 and this will give you minus 2 by 2. Now if you want to represent minus 1 by 4 on the number line, minus 1 by 4 on the number line, or if you want to represent minus 3 by 4 on the number line. So you divide the space between 0 and minus 1 because this number lies between 0 and minus 1. 0 and minus 1. So you divide the space into, as denominator is 4 equal parts, 1, 2, 3 and 4. So this one will give you, what is this? This number will give you, this number will give you, it is minus 1 by 4 and this will give you minus 2 by 4 and this will give you minus 3 by 4 and this will give you minus 4 by 4. Minus 4 by 4 will give you. Therefore, minus 3 by 4 means this point will represent minus 3 by 4. So like this we will represent the rational numbers between two rational numbers. By dividing, the first thing it is we have to identify the given rational number lies in between which two numbers. Then you divide that space into equal parts, which is equal to the denominator of that given rational number. Then we can represent the required rational numbers. Is it clear, children, how to represent the rational numbers on the number line? Yes, we will discuss some of the examples. Yes. Now, an example. Represent the following numbers on the number line. Yes. First bit we have 7 by 4, then minus 5 by 6. Third one is minus 7 by 4. So you represent them individually on the different. What I mean to say is different number lines. Individual number lines. See the first one, it is 7 by 4. 7 by 4 is an improper fraction. And its value is more than 1. 7 by 4 more than 1 and less than 2. So it lies in between 1 and 2. So this is, let this is 0 and it is minus 1. It is 1 and it is 2, like this. So this number 7 by 4 lies between what? 7 by 4. 7 by 4 is less than 2 and more than 1. 7 by 4 is less than 2 and more than 1. So it lies in between 1 and 2. So here the denominator is 4. Divide the space between 1 and 2 into 4 equal parts. 1, 2, 3 and 4. So 1 it is, 1 means what we can write as what? 4 by 4. The denominator as 4 by 4. Then this one is 5 by 4. Then we have 6 by 4. Then 7 by 4. Then this is 8 by 4. 8 by 4 in the sense what it is? 2. 4 by 4 ones are 4 twos are 8. 4 by 4 which is 4 ones are 4 ones are 4. We'll get it. Now 7 by 4. Yes. This point is the 7 by 4. Like this we will represent 7 by 4. Next, the second bit here we have minus 5 by 6. So you have to find this minus 5 by 6 is what it is less than 0 and more than what it is minus 1. So minus 5 by 6 is less than 0 and more than minus 1. Now you take the negative integer, let this is 0 and it is what it is 1 you take, and it will extend this one till here, you take this as 1 and it is minus 1. Now we have to divide this space into 6 equal parts as the denominator is 6. 1, 2, 3, 4, 5 and 6. Now this one will become what it is 0 means it is 0 by 6 and this is left side. So we will get it as what? Minus 1 by 6, minus 2 by 6 and this is minus 3 by 6, minus 4 by 6 and minus 5 by 6. This will be minus 6 by 6 which is equals to minus 1. Now minus 5 by 6 where we have? Yes, this is the number. So you can represent that here minus 5 by 6. Next, similarly, minus 7 by 4. Third one it is minus 7 by 4. So minus 7 by 4 is what? It is more than minus 1 and less than minus 2. Minus 7 by 4 is more than minus 1 and less than minus 2. So it lies in between minus 1 and minus 2. Let this is 0 and it is 1. It is minus 1 and it is minus 2. This is minus 3. Now divide the space between minus 1 and minus 2 into 4 equal parts. That is 1, 2, 3 and 4. So minus 1 in the sense it is minus 4 by 4 and this will be minus 4 by 4 and this is minus 5 by 4, minus 6 by 4, minus 7 by 4. This is minus 7 by 4 and it is minus 8 by 4. Minus 8 by 4 is equals to minus 2. So we have to represent minus 7 by 4 means this is the point. So this point will give you minus 7 by 4. So like this we can represent the rational numbers on the number line. Is it clear, children? and thank you very much.